Alright, let's look at the determinants. Alright, when you have a 2 by 2 matrix, let's say matrix A is A, B, C, D, then the determinant of that matrix A would be simply A times D minus B minus C. Alright, so that's how it's defined. So if you have a 2 by 2 matrix, you can simply use the formula. But what if you have a bigger matrix, 3 by 3, 4 by 4, 5 by 5? Then first we need to learn something called the minor, right? Minor is let's say you start with the matrix, original matrix. So I'm gonna put A11. So let's say n by n matrix. So A11 all the way to, I'm gonna put the AI1 here, and actually that's wrong, and it's a first row and it's a J here, and all the way to A1N. Then AI wants to go down, and you have a, let's say I1, and then here AIJ, and then you have a AIN here. Then go all the way down to AN1, and then go all the way to ANN. Right? So this is the original matrix, and what we do is we eliminate, we basically erase ith row. So you have a ith, so this is the ith row. You erase the ith row, and then you're going to look at the jth column. Also, you erase it, right? Then you would end up with the n-1 by n-1 matrix. And what we're going to do is just take the determinant of that matrix. All right. So if you start with the 3 by 3 matrix and erase one row and one column, you end up with 2 by 2 matrix. Then you can use the 2 by 2 matrix determinant formula to find the minor. All right. And there's something called the cofactor, which is just a signed minor. All you have to do is you determine the sign by -1, raise it to the I plus j, right? Then you multiply by minor mij, right? So this is called the cofactor, right? Once you know those two things, we can define the n by n matrix, right? So this is going to be n by n, determinant for n by n matrix. All right. So what we can do is you pick maybe any row. So let's say I'm gonna pick row I. So I goes from 1 to let's see. Oh, actually, row I. All right. So let's say you have a row I, and I'm gonna just put the AI1, AI2, and so on. Then you have AIN, right? So you pick any row. So I'll just in general, I'm gonna say ith row. All right. Then what we're gonna do is we take row I, and j starts from 1 to n. Then multiply by its corresponding cofactor. So Cij. So you start with AI1 times Ci1 plus AI2 times Mi2, Ci2, sorry, and so on, and all the way to AIN times CIN. So this is for any row I, where I is, maybe I'll write it this way, I is 1, to all the way to n. Alright, so that's done along the ith row, but you can actually do it the jth column as well. So let's say you have jth column. So I'm going to just, maybe I'll use a different color there, and say here. So you have A, let's see, 1J, A, 2J, and so on, and A and J. So we're looking at the jth column. Alright, then we can also, in order to find the determinant, we can do it along the jth column instead of jth row. So all you do is I goes from 1 to n, A, I, J, and C, I, J. So this is again for any j from 1 through n. Right, so you can expand it along the any row, and you can expand along any column. So pick the most convenient one to compute. Then once you compute that, it's going to give you the determinant of n by n matrix. Right, that's it. I will go over an example in the next video. Alright, that's it. I hope that this was clear.